Okay, let us see question number 34th of this calorimetry set. You can read the question and obviously you will not be able to understand. So here what is happening is, like, I hope you have read the question just for formality sake. So this entire cooling water, this is cooling water, and this cooling water is going to cool the device which is producing a lot of heat. So this is cooling water which is 120 liter, which means 120 kg also, and this is initially at 10 degree. So what we are going to do is we are going to feed or throw this cooling water here. So cooling water goes and there is a hot device. So hot device, lot of heat is getting generated, 3000 watt or 3000 joule per second is getting generated. So what will happen is this device will lose this 3000 of joule per second to this cooling water, because that's the job of cooling water. Cooling water is supposed to cool. So as this cooling water keeps flowing, it keeps on picking the heat until a time comes when it is about to come out. And when it is about to come out, it should take away this 3000 joule of heat from this device. Obviously, when this water will pick up 3000 joule of heat from this device per second, it will become hot. And because it will become hot, so by the time it comes back to the cooler, now it has become hot. But there is a problem. If it becomes hot, then we can't send it back. So what we need to do is, the returning water has become hot, so let us cool it. How? By using a water cooler. Now this water cooler can take away P joule per second or P watt. So let's say P watt. Let's say P watt is like a 3500 watt. Oh, that will be just too much brilliant. Why? Because how much is the water getting heat per unit time from the device? That is 3000 joule per second. That is the heat which is gained from the device. And what is the heat which is extracted from the water? 3500. So if you take this entire water as a system, which was initially at 10 degrees centigrade, it is gaining 3000 joule of heat from the device, and it is losing 3500 joule per second through the cooler. So there is some cooling mechanism which is not shown, and that cooling mechanism is cooling the cooling water inside the cooler and taking away 3500. So if initially the temperature of the water is 10 degrees centigrade and it is gaining 3000 joule per second, it is losing 3500 joule per second. So overall lost will be like 500 joule per second. And because of continuously losing 500 joule per second, this entire water as a system will start getting its temperature reduced. And then there is no problem as such. But that will be like using too much capacity of the cooler. What happens if we use the cooler which can extract only 3000 joule per second? In that case, the water temperature will remain 10 degree only. Why? Because how much is the water gaining per unit time from the device when it goes into the device and picks up heat from the device? From the device, it takes up 300 joule per second. But how much it loses to that cooler when it comes to the cooler after passing through the device? It is losing 300 joule per second. So gaining also 300 joule per second, losing also 300 joule per second. And so what will happen is its temperature will remain constant at 10 degrees centigrade. I mean, when it will go to the device, its temperature will increase from 10 to some higher temperature. But when it comes to the cooler and again loses the heat, again its temperature will become 10 degree. And once it has lost the heat to the cooler and it is again at 10 degree, it will be sent back. And again it will pick up the heat from the device, 300 joule per second. It will become hot at some higher temperature, T degree centigrade. And again, by the time it comes to cooler, it is at T degree centigrade. Now it will lose heat and cooler will cool it. and again it will extract the 300 joule which it has taken from the device and make it come back to this 10 degree centigrade, and the 10 degree centigrade will be fed into the device once again. But what if we use the power of the cooler to be less than 300? Now there the problem begins. What is the problem is, let's say this water when sent to the device is picking up 3000 joule per second from the device and coming at a higher temperature of T degree centigrade, which is greater than 10 degree centigrade because it has picked up the heat. But now when it has come here, it is going to lose. And how much it loses? P joule per second or P watt, but P is less than 3000. Let's say P is only 1000. So gaining was 300 joule per second when it was spending time in device, and losing is only 1000, which means how much is the overall gain in one cycle? 2000 joule per second. Because of which what will happen is, overall gain is 2000. Slowly the temperature will rise. So if initially it was at 10 degree centigrade, then it will come to 11 degree, then 12 degree, 13, 14, 15, 16, and as the time keeps progressing, every second on an average this entire water which is circulating is gaining 2000 joule per second, because gaining is 3000 from the device and losing is only 1000 from the cooler, because cooler is now of very poor capacity. Cooler can extract only 1000 joule of heat per second, and we have used actually a very pathetic cooler, very cheap cooler, and we are going to destroy our device. Why? Because as the time progresses, there is an overall gain in heat, because of it there is an overall rise in temperature of the water, and as the water keeps increasing in temperature, a time comes when the water temperature exceeds 30 degrees centigrade. And once the water temperature exceeds 30 degrees centigrade, the device will be spoiled, and so we will be paying the price of this device. So what we need to do is, we need to see, we can use the device of power less than 3000 joule per second, but it should not be that much less, so that overall rate of gain of heat is so high that the temperature becomes greater than 30 before 3 hours. In worst case, we can use a lower capacity cooler, so that lower capacity is less than 3000, so that the water keeps gaining heat anyways per unit time on an average, and because of that it keeps gaining temperature, but its temperature because of gain should not become like 30 degrees centigrade in 3 hours. So let us say that we have used a cooler of capacity P joule per second, so that after 3 hours the temperature of water has become 30 degrees centigrade. Okay, so at T equal to 0, what was the temperature? 10 degrees centigrade. At T equal to 3 hours, 3 hours means how many? 3 hours means this into this, 16 to 60, and this is seconds. In this much seconds, how much is the temperature? 30 degrees centigrade. This is the limiting case, all right. And how much is the heat gained? 3000 joule per second is the heat gained. So total heat gained from device is equal to 3000 joule per second. What is the heat lost? The heat lost to cooler is equal to P joule per second. But we are not talking about per second now, isn't it? And so we will multiply it by the time. So 3 into 3600 seconds, 3 into 3600 seconds. What is the overall gain in heat? Overall gain in heat by water in 3 hours, and that is equal to 3000 into 3 into 3600, which is the heat gained, minus the heat which is lost to the cooling cooler. And if this is the overall gain in heat, divide this gain in heat or equate this gain in heat to ms into delta T, and delta T is T minus 10. So that will be equal to like, so just copy this, and mass is like 120 kg. Specific heat capacity is, I think, given in the question to be 4.2 kilojoule. So 4200. So temperature at the end of 3 hours will be equal to this plus 10. And what do we require? We want that this temperature should be less than or at max equal to 30 degree. So this inequality you have to solve, and after solving this inequality you will get the answer. So 3000 into 3 into 3600 minus P into 3 into 3600 should be less than equal to 4200 into 120 into 20. So like many things will get cancelled out, and I think you should be able to get the value of P from this.